Hello, good morning students. Welcome back your chemistry class in organic section. Okay, so in the previous online and video classes we'll be sending you some organic reaction mechanism like your hyperconjugation, resonance effect, inductive effect, electromeric effect. Okay, all these type of effects and reaction mechanism we'll be sending in the video classes. Okay, and now today we'll be continue with the new article in this organic section, that is your reactive intermediates. Okay, so here reactive intermediate, that is most of the organic reaction that is occur through the involvement of certain chemical species. Okay, they have already started, we discuss in this section ki all the organic reaction that is occur through a some chemical species. These chemical species very short lived, okay, and very high reactive, and hence cannot be isolated. Okay, very reactive है, very short lived है, or you can be isolated these type of chemical species. So this short-lived highly chemical reactive species through which the majority of the organic reaction we called as reactive intermediate. Okay, they are classified into, they can be categorized, some example related with your carbocations, carbanions, free radical, carbenes and nitrine. All these intermediates be explained in terms of carbocations, carbanions, free radical and carbenes and nitrines. Okay, so firstly we discuss your carbocations. Okay, carbocation is what, that is a simple chemical species where a where a positive charge, means ki they carry the positive charge on carbon and carry the 6 electron in its balance shell. Okay, and that we called as carbocations and carbanium ions, sometimes we called as carbonium ions. These are found by the heterolytic cleavage of the covalent bond. You have already learned what is the heterolytic cleavage of covalent bond, in which the leaving group takes away with its a share of electron. So you can see that is your heterolytic cleavage. Okay, tetrabutyl chlorides, that is a heterolytic cleavage. So here that is lose electron from this carbon and gain of electron from this carbon by the chloride. So this chlorine is converted into chloride ion. This is a heterolytic cleavage and this is the formation of carbocations. Okay, tetrabutyl carbocation. Okay, so classification of carbocation, that is primary, secondary and tertiary according to the positive charge that is present on the primary, secondary and tertiary carbon atom. I am already discussed in your lecture, okay, which how to identify the carbon primary atom, secondary carbon atom and tertiary and quaternary carbon atom. Okay, I am already explained. So this is your primary because they have only one alkyl group attached this carbon. Similarly, they have two in this carbon atom attached, that is why we called as secondary, and there is a three alkyl group attached with this carbon atom, that is a tertiary. So the order of stability of carbocation, that is tertiary, is more stable as compared to secondary and primary. So firstly we discuss how to stabilize. Okay, first is inductive effect. According to the inductive effect, that is plus I effect is responsible for the stability of carbocations. So when the electron donating group is present in the tertiary carbocations, any carbocations, when the alkyl group is attached to positively charged carbon atom of a carbocation, this is also your electron donating because they have the alkyl group. So this alkyl group attached to this carbon atom, they can donate electron, means say that after releasing from this side, it tends to release electron towards the carbon, means they have released from this sides and they can donate the electron from this carbon and this carbocations can be stabilized. So that's why the tertiary carbocation is more stable as compared to secondary and primary, because they have the three alkyl group. They have the more possibility for to stabilization of carbocation as compared to secondary and primary. Here is two alkyl group and here one is one. Okay. So students, this is given your stability about the carbocation. So you can see that is a 3 alkyl group that is more stable as compared to the primary and methyl carbocations. Okay, and the stability is decreased from this side. This is less stable as compared to this. Okay, this is a stability decrease according to this pattern. Next is your resonance effect. The resonance effect is also stabilize the carbocations. So carbocations in which the positively charged carbon atom is attached to double bonded, that is carbocation is attached to double bonded as be connected with the benzene ring. So this can be stabilized by using the resonating structure. So you can see that there is a movement of this pi electron from this side, and here is carbocation is to be stabilized because here is two hydrogen is attached to this carbon and this carbon is again attached to double bonded. So here is complete for tetravalency, but here is not possible. So this is your for moving positive charge this carbon. Okay, similarly in the same pattern here the cleavage of double bonds to move from this side, this acquire the positive charge on ortho position, second is para, and then again move from ortho position and they again obtains its original position. So more the number of phenyl groups, greater the stability. So this is a phenyl C6H5. Okay, so here that is can be removed from two hydrogen with attachment of phenyl group C6H5 or be attach of this benzene again from this carbon. Okay, so more the phenyl group and more the stability. Similarly for hyperconjugation, hyperconjugation is what? That is the release of sigma electron from the carbon and hydrogen bond. Okay, after this releasing of sigma bond and this bond is moved from this side. Okay, this is a one structure, again from removing from this side, this is second, and again removing from this side, that is your third structure. Okay, this is for a one methyl group. This is related your questions from your tertiary carbocation. Okay student, this is explain about this. ये हमारे पास example है. This is your one methyl group, this is your one एल्काइल या मिथाइल ग्रुप, दैट इज योर डिस्प्लेस. ये एक की बात की गई है, थ्री हमारे पास स्ट्रक्चर्स प्रोड्यूस हुए हैं. बट व्हेन यू कैन बी एक्सप्लेन यू कैन बी ट्राई टू फ्रॉम नेक्स्ट टू, दैट इज सेकेंड एंड दिस इज थर्ड. सो अगेन इज रिप्रेजेंट इन योर बुक +6 मोर सच स्ट्रक्चर फ्रॉम द टू मिथाइल ग्रुप. फर्स्ट का हमारे पास 3 स्ट्रक्चर्स हैं and rest of the 2 they given the 6. That means there has a 9 possibilities of alpha hydrogen and hence the 9 hyperconjugation structure. More the conjugation structure, that means ki more the stability of the carbocations. So that's why tertiary butyl carbocation is more stable as compared to the primary and secondary, because they have the more possibility for the hyperconjugation effect. Okay, next is your Carbanions. Okay, Carbanions, when the chemical species bearing a negative charge on carbon and possessing the 8 electron in its valence shell is called carbanion. Simply say that ki carbon acquire the negative charge. Okay, so hereafter the 6 electron to be gain of 1 electron pair is converted into 8 electron, that we called as a carbanions. Okay, similarly same concept is used in carbanions by using of the carbocations. So students, this is your carbocations for related your example. They have explained about the carbocations. So carbocations can also be classified into primary, secondary and tertiary. So according to the negative charge present on the primary, secondary and tertiary carbon atom, that is respectively, that is primary carbanion, this is secondary, and this is a tertiary. I hope you all understand what's about meaning for the R3, R2 and R1. This is simple alkyl. This is 2 alkyl group attached, that is your R2, and this is a 3 alkyl group R3, and alkyl group is your CH3. Okay, so stability of the carbocation, that is explained on the following factor, that is the inductive effect. So here that is your simple carbocations in simple methyl. Okay, that is also be more stable as compared to primary, secondary and tertiary. This is the reverse order of कार्बोकेटाइन. ओके, कार्बोकेटाइन में टर्शरी कार्बोकेटाइन इज मोर स्टेबल, बट कार्बेनाइंस में हमारे पास सिंपल मिथाइल आइंस दैट इज मोर स्टेबल एज कंपेयर टू प्राइमरी, सेकेंडरी एंड टर्शरी. So on the basis of inductive effect on the alkyl group, so alkyl group of plus I effect, that is electron donating group. So alkyl group is attached to negatively charged carbon atom of the carbanion. It tends to release electron towards the carbon atom, and it's increase the intensity of negative charge on the carbons, and it's destabilize the carbanion. So here how can to understand, हमारे पास मिथाइल कार्बेनाइन है, दैट इज अ सिंपल मिथाइल कार्बेनाइन. देयर इज अ नो प्रेजेंस ऑफ एनी मिथाइल ग्रुप, मीन्स कि कोई भी मिथाइल ग्रुप प्रेजेंट नहीं है. दैट मीन्स कि नो डोनेशन ऑफ इलेक्ट्रॉन बाय द मिथाइल ग्रुप, नो डोनेशन बाय द डोनेशन ऑफ इलेक्ट्रॉन बाय द मिथाइल ग्रुप. दैट मीन्स कि नो इंक्रीजिंग द नेगेटिव चार्ज. जैसे हमारे पास एल्काइल ग्रुप हुआ है, ये इलेक्ट्रॉन अपने यहाँ से एल्काइल ग्रुप रिलीज होगा, अपने इलेक्ट्रॉन छोड़ेगा. दे इंक्रीज द नेगेटिव चार्ज फ्रॉम दिस कार्बन एटम. Again 2, they again release so donation of electron, that is increase on the carbon atom. So जैसे जैसे अल्काइल ग्रुप इंक्रीज होंगे वैसे वैसे ही इलेक्ट्रॉन डेंसिटी इंक्रीज होती जाएगी कार्बन के ऊपर. किसी भी पर्सन्स के ऊपर जब एक्सेस जितना वो अपना वेट किसी चीज़ का ले सकता है उससे एक्सेस में हो जाता है तो वो क्या हो जाता है, गिर जाता है, ये वो डिस्टेबलाइज होता था. सेम कंसेप्ट इन हियर कि when the methyl carbanion is can be stabilized, but when we increase from primary to tertiary, so that is the decrease the stability because they have the attachment of alkyl group on this carbanion and it destabilize of this carbanion. That's why this is the right pattern for the stability of the carbanions. Similarly, for resonance effect, they can also be stabilized. So here this carbanion can be donate electron from this, and here bond is cleavage to move from this side, ortho para and again ortho position, and they can be stabilized by the resonating structure. Okay. So this is about a structure. But according to the more number of phenyl group attachment from this carbon, so it can be stabilize the carbanion because this negative charge can be moved from this like one benzene structure. Again you can attach from this side. So this negative charge can be revolved into three different phenyl groups and it can be stabilized by the resonating structure. Okay, this is about the carbanion. Next is your free radical. Okay, so free radical is that is may be defined as atom or group of atom having an odd or unpaired electron. फ्री रेडिकल्स हमारे पास क्या है, किसी भी एटम के ऊपर ये ग्रुप ऑफ एटम्स के ऊपर क्या रहता है, ओड नंबर ऑफ इलेक्ट्रॉन, जैसे 1 3 5 7. ये भी कॉल्ड एज अ अनपेयर्ड इलेक्ट्रॉन, मीन्स नॉट अ totally paired. Paired is when the two electron present in any atom or group of atom. This is your unpaired and odd. So here is the homolytic cleavage by forming the free radical. This is by forming the free radical. When the chlorine molecule is dissociate and convert into chlorine atom in the form of free radical. Similarly, that is your methyl dimethyl group is also convert into methyl free radical. This is wrong. This is not chlorine. That is your dimethyl group. This is peroxide after cleavage of this oxygen bond to convert into alloxy free radical. Okay. Similarly, carbocations and carbanions, they have the free radical is also classified into three categories, that is primary, secondary and tertiary free radical. Okay. So order of the stability of free radical is same as that of the carbocation. Okay, because after releasing of electron they can release and here be complete a paired electron formation. Okay, so order of stability can be explained on the basis of hyperconjugation. Greater the number of alkyl group attached to the carbon atom carrying the odd number of electrons and greater the delocalization of odd electron and hence the more stable in the alkyl free radical. Okay, so this is about your reactive intermediates. Okay, so students, next topic is your common type of organic reaction. In the organic reaction they have the different categories of reaction. They have categorized into A types. Okay, so you just be go through for this type of reaction in organic section because you have learned in the next class in the 12th standard. This is just to be overview about what is substitution, what is elimination, what is addition, rearrangement, condensation, isomerization, per cyclic and polymerization reaction. ठीक है, this is the 8 categories of organic reaction. You just go through and just be understand about which type of organic reaction is tell about. Okay, so first is substitution. The name of substitution reaction is just be understand about ki to be replacement, direct the replacement of atom or group of atom in the organic molecule, that is a substitution reaction. Okay, and they have the again three categories of substitution, that is a nucleophilic substitution, elimination and So students, under the substitution reaction, they also categorize into three forms. Okay, that is a nucleophilic substitution reaction, elimination. Say that nucleophilic substitution reaction, electrophilic substitution, and free radical substitution. They have the three types of substitution reaction. Okay, so under the nucleophilic substitution reaction, they also be categorized into two forms. That is SN2 and SN1. SN2 that is a bimoleculars and SN1 that is a unimolecular reaction. Okay, second is your addition reaction. Okay, students, you just overview what say that about this reaction. Okay, in the next class we study about in deeply section. Okay, so that is the second type of organic reaction, that is a addition reaction. So in this reaction what happened, the reaction is involve the combination between two reacting molecules to give a single molecules. Means say that कि here the reaction is involved the combination of two reacting species molecules है combine कर रहे हैं और make क्या कर रहे हैं to give a single molecules of product that we called as a addition reaction. Okay, so here the such reactions are typical of compound for containing the multiple bonds. Typical reactions कहाँ रहेगा, जहाँ पे multiple bond present रहेंगी. And this type of reaction is depend upon the nature of attacking species. ठीक है, this type of reaction कहाँ पे depend कर रही है कि attacking species कैसा है हमारे पास. And this type of reaction is also into three types, that is electrophilic, nucleophilic and free radical addition reaction. Okay students, this is about the addition reaction. Next is elimination. So third type of elimination reaction, the elimination reaction in one that involve the loss of one, two or group of atom from the same or adjacent atom of a substance leading to the formation of multiple bonds. Okay, सिंपली हमारे पास जैसे ये कॉम्प्लेक्स है क्लोरोफॉर्म. ओके, यहाँ पे एलिमिनेशंस क्या रहेगा, दैट इज योर रिमूवल ऑफ द हाइड्रोजन. ठीक है, यहाँ से रिमूवल ऑफ हाइड्रोजन रहेगा फ्रॉम द अल्फा पोजिशन, बीटा एंड गामा. अल्फा बीटा गामा फॉर यू फर्स्ट कार्बन, सेकेंड कार्बन, थर्ड कार्बन. फर्स्ट फॉर अल्फा, सेकेंड बीटा एंड थर्ड फॉर गामा. Okay, so elimination reaction is one that involves a loss of two atom or group of atom from the same or adjacent atom of a substance. जहाँ से भी हमारे पास एटम लूज करेगा, ठीक है, ये ग्रुप ऑफ एटम लूज करेगा, आफ्टर लूजिंग ऑफ दिस इलेक्ट्रॉन दे हैव लीडिंग टू द फॉर्मेशन ऑफ, जहाँ से बॉन्ड क्लीवेज होगा वो फॉर्मेशन किस चीज़ की करेगा, फॉर ए डबल बॉन्ड्स के लिए. So this is your beta elimination. So you can see that here is single bond, but in case they have the formation of a double bond. Okay, because here the elimination of hydrogen from beta carbon. So here CH3 is released from one hydrogen, so convert into CH2, and here the one bond is to making a multiple bond. This is your elimination reaction. Okay, next fourth is your condensation. In this reaction, two or more molecules of the same or different reactants combines to form a product with or without the elimination of simple molecules such as water, HCl, ammonia, hydroxy, etc. मीन से दैट सिंपल यहाँ पे व्हेन द टू और मॉलिक्यूल्स, कोई भी दो मॉलिक्यूल्स हैं, सेम भी हो सकते हैं, डिफरेंट भी हो सकते हैं, कंबाइन करते हैं. ठीक है, कंबाइनेशन मतलब जो भी रिएक्टेंट मॉलिक्यूल्स है वो कंबाइन करेंगे. आफ्टर कंबिनेशन दे गिव अ वन प्रोडक्ट विदाउट लूज ऑफ एनी. जो भी मॉलिक्यूल्स, जो भी रिएक्टेंट दैट इज कंबाइन करेंगे वहाँ से कोई भी साइड प्रोडक्ट लूज नहीं होगा. जैसे लाइक हमारे पास HCl है, वाटर है, अमोनिया, इस तरह का कुछ भी नहीं निकलेगा. यहाँ आप देख सकते हो two reactant that is combined to each other and they making a one product without lose of any side product or simple product, that is a without the elimination of simple molecule that is such as water, HCl and ammonia. Okay, this is about the condensation reaction. Okay, next is your rearrangement. Rearrangement simple, you have already learned in the tautomerism. Reaction involving the migration of one atom or group of atom from one atom to another with the same molecule is called rearrangement. Okay, so in the tautomerism you also study about 1,2 migration and 1,3 migration. Simple, that is arrangement from hydrogen atom from one atoms to the another in the same molecule, that is a rearrangement reaction. Next is a isomerism या isomerization reaction. Reaction in which involves the interconversion of one isomer into another by keeping the molecular formula as well as the carbon skeleton of the reactant and the products intact are called isomerization reaction. So here interconversion of trans but to ene. Trans say that कि यहाँ पे एक alkyl group है, यहाँ पे in the opposite direction. When the two atom or group of atom present in the opposite reaction, that be called as a trans. Similar, this is a hydrogen in opposite direction, that is be called a trans. So after interconversion, okay, by keeping the molecular formula as well as the carbon skeleton, so this is reactant is convert into cis form. So this is cis form, that means ki two atoms or group of atom that is present in your same site. Okay, this is your cis and this is your transform. Okay, this is your isomerization reaction. You study about cis and trans in a stereo isomerism. Okay, in 12th standard. Next is a percyclic reaction. Percyclic reaction simple. This type of reaction when the bond making and bond breaking occur simultaneously. Bond टूटेगा बनेगा, that is a percyclic reaction. और जो भी reaction यहाँ पे proceed करेगा that is under on your heat or light. They do not require any type of catalyst. They just required for your heat and light. So all the reaction that is carried out in the heat and light and to making and breaking a bond, that be called as a percyclic reaction. Okay, so they have a example in front of you how to understand the percyclic reaction. Here the ethene that is converted into cyclobutane. So you can see that that is the cleavage of double bond, and this cleavage of double bonds to make a single bond. Okay, here is breaking and here is making by the using of heat. Okay, and they form a cyclobutane complex. Okay, according to the percyclic reaction. Next is a polymerization reaction. This reaction involves the union of large number of small molecules is called monomers. This reaction involves the union of large number of small molecules. This is your one unit. Okay, that is be monomer. ये मोनोमर्स अगेन अटैच होगा सेकेंड के साथ, अगेन थर्ड जैसे चेन बनती है हमारे पास, दैट इज वन, दिस इज योर लाइक योर one unit, they combine with this unit, they combine with this unit. So this is one unit be called as a monomer. Similarly case ethylene is one monomer, they again attach with this again same molecules and to make a polythene. So this is polymerization. This reaction involves the union of a large number of small molecules called monomers to form a molecules with higher molecular mass, we called a polymer. एक small monomers के साथ यानी कि small मास ऑफ मोनोमर्स के साथ वो कंबाइन करके क्या बना रहा है, एक हायर मॉलिक्यूलर मास की फॉर्मेशन कर रहा है, दैट बी कॉल्ड एज अ पॉलीमर. दिस इज योर पॉलीमराइजेशन रिएक्शन. ओके स्टूडेंट्स, so next time we discuss about the purification of organic compound. You have already learned in your lower classes about this purification of organic compound. They have the under some method, that is filtration, crystallization, fractional crystallization, simple distillation, distillation, fractional distillation, sublimation, chromatography. All these technique you have already learned in the 9th standard. You just recapitulate about in this section. Okay, so next time we'll be discuss about the purification of organic compounds. So thank you and have a nice day students. Do understand about the today topic.